Start record. Alrighty, for those who are watching this after the fact, we've cloned this project being github.com/explodingsocks/js-alt-october 20. It's in the meetup link, but October 2016. It'll be in the description of the video. I'll just drop it there. We went to that, downloaded the repo, and then we did npm install. And then we did npm start right here. So we've now got a static server running. Let's actually just look at the project and we can explain what's going on. So I'm going to open up Atom because it's my editor of choice, mostly editor of choice. And let's take a look at what we've got in the project, because one of the things that I faced when I first started using Purescript was like, what are all the parts that go into this, and like, why can't I get anything? What is the basic skeleton and structure that I need to get things going? Because I would clone down like Puck's starter, and there's a lot of stuff in there for like hot reloading and webpacking and all the extra stuff that you do want eventually, but you don't need to just learn how the language works. So this is a really, really bare bones thing. So let's look inside the Bower JSON. Purescript uses Bower as its package manager, and it may forever, who knows. But inside of here, the only things that we've installed are Purescript Pucks. Pucks is going to be the framework we're going to use for rendering the app to the web stuff. And then we've got PSCI support. So PSCI is the compiler, like the interactive compiler, and it's gonna let our IDE do helpful stuff. And then arrays, I forgot to uninstall that, but that's in there. We don't need to use it yet. We might want to use it soon. So that's all we've got in our Bower JSON. Then we've got a nice little static index here. And this index file is loading in React. It's loading in Bootstrap for some styling. And it's got this div called app, and that's all. That's all that happens there. And then installed in our package JSON, we've got browser sync for doing a static serve and an auto reload. We've got PSCID, which is a nice little tool that helps rapid development when you're writing Purescript. It'll do compilation, like super fast compilation of just the files that you're editing while you're editing them. So that makes it nice and fast. Pulp is a build tool associated with Purescript. It's got some nice environment stuff set up, some nice defaults that take care of things for you. And you don't really need to worry about the others other than Purescript. Great. Welcome. All right. Okay, so in here we've got our actual source files. Let's go look at those. We've only got 2. And I need to...
Thanks. Oh, did you just get rid of the rest of it? Yeah. So I was like, there's something different with the face.
I find it easier to reveal a mustache.
I'm going to kill all node. I've got weird stuff happening because I moved things to a weird place. So I'm going to PSCID restart or reload. PS, thank you. Yeah, PSCI reset. No, what was that? It's Purescript restart PSC IDE. Okay, so this is a plugin for Atom that will like try to give me linting and errors and stuff shown to me nicely. So that's what's going on there. So here, inside of our main doc first, let's look at what we have. Prelude. Do you know what Prelude is? Let's go over it for people who are watching the video just in case. Prelude is a bunch of the batteries that get included that you want to do stuff with the language. So there are things like map. There's a function called map in the language Purescript that will operate on anything that implements map. So anything that's a functor. And that, instead of finding like inside of the string library, like we were saying earlier, inside of the string library where you find a string map, you would just use map from Prelude, and you'd be able to use it on any functor, anything that implements map. So that's what, we got some stuff from there in Prelude. And I don't know why we had to import it right here. I don't remember. But I'm not going to worry about that right now. And then we're going to import our name generator, which we'll go look at in a minute. But we've got our update function, our view function, and our init function. Now this is really Elmish. So this is like, it's basically just following the Elm pattern is what Pucks does. We've got the starting model, the view function that returns HTML after getting the model and rendering it, the update that'll take an action and the model and give us a new model. And then we've got 3 simple functions here from Pucks. One called render to DOM, which is basically the same as React, rendered to DOM. And then you get from simple. From simple says, we're going to do an app without side effects, just one that runs the update function and updates the model. And start. So here's where it starts to get a little cooler, a little bit more monadish. So we start out the main function with a do block. Now, do is syntactic sugar for, I don't know how deeply we should go into monads here, but monads are basically just containers that you can flat map over. So like a good example of a monad is a list, because you can take a list, you can map over the items in a list, and you can return lists in those maps that you're doing. And if you return a list and you do a flat map over it, you end up with one big long list instead of a list of lists. That's basically what you can do with a monad. But it applies in much more situations than just a list. In fact, the abstraction is so powerful that you can do things like chain-dependent procedures and make it look as if it's procedural in a way. It look as if it's not object-oriented, imperative, thank you. Make it look as if it's imperative when it's actually still declarative. And so there's syntactic sugar that's provided by Haskell and by Purescript, but not by Elm, that makes sequencing things just a little bit easier on the eyes. And so what we do here is we start out a monadic sequence, and we basically are naming a variable right here. What we're going to do is we're going to run this start function, which is in a monad, and what we're going to do is lift its value out of the monad into the current execution context with this arrow. So this is, if that made no sense at all, this is basically like, you could think of it as if the variable app is getting assigned the value returned by calling start. That's kind of effectively what it is. App gets bound to whatever comes out of start, and then we can reuse it. So app, once you call start with the initial state, gives you basically a packaged up object that's going to have a stream of HTML that we can hand to render to DOM. So down here on render to DOM, we're going to pass it a string, and we're going to pass it the app with the HTML. Now, we should probably look at the types for this, because it might get a little confusing. Like, you might think, well, how did I know I was supposed to do that? Let's go look up Purescript pucks. And then let's go look at the API reference for it. They got some nice API docs. Loading them up. Okay, so pucks, start. The start function, that does not look simple, does it? Well, let's see if we can break it down a little bit. So, for all state action F. So what this means is that this is a parameterized type. Purescript has what's called row polymorphism, which means, it probably means way more than what I'm going to say here. But basically it means that you can have types that are polymorphic without inheritance. So you don't have to say like, oh, this type is a something. Oh no, I didn't have any idea that the free account had a limit. So maybe we'll have to end the meeting and then start it again. We'll see. I might lose you guys remotely. We'll see if we do. But I'm going to stay with free. If we lose it, then we'll try to come back into the meeting in a minute. All right, so our start function is parameterized. It's got state, action, and effects. So these three things are not solid. You're going to define that by the types that you pass it. And so what you're going to pass as the first argument to this function start is a config. And the config is also parameterized. Config state action F. And then you're going to get back an F monad. So this is where we were talking about earlier, having the do block and having to list stuff out of a monad. You get back this thing that's called F. And that's an actual library that's in Purescript. You can go look up. And this F is parameterized with the types, this F is a product type. So it's got multiple fields in its type. And those fields are core effects, F, and app state action. So you don't really need to worry about that. All you need to know is, okay, we get back an F monad, and it's going to have an app in it. That's basically all you need to know right there, is that we need to pass in a config, and we're going to get back an F with an app in it. So let's look at config. Okay, so config, type config is a record. It has an update function, a view function, an initial state. This is all looking really familiar. And once you start to kind of carve out some of the stuff that maybe isn't so familiar if you're used to Elm, or maybe is really familiar if you're used to Haskell, that's fine. But But you could start to see through and say, oh, this isn't so complex. You know, I don't really need to worry necessarily about things that could be horribly confusing. So let's go up to right here where it says app, and let's find where that app definition is. App is also a record with a signal of HTML and a signal of state. And so that's why over here, we knew that we could access .html on an app, because once we called start with this config object, and we knew that we were pulling app out of the fmonad, we were just getting it out of there so we can work with it, then we could call app.html and pass that right in to render the DOM. So we're not going to go through the whole code like this. I want you guys to get started programming. But let's jump in here, and let's just actually basically write this out. I'm going to delete a bunch of stuff. So boom, get rid of that, and get rid of all that stuff right now. Let's just have an empty string for our model. It's an init. I'm sorry, an empty string for our init, and the model is just going to be a string, the state there. And then for our update function, let's get rid of that. Let's just focus on why everything is breaking. And maybe I should just disable that plugin for now. Purescript. Disable for now. Okay. Okie dokie. So it restarted. We might need to reload the editor. Okay, so now we've just got an empty div for our view state, and we're going to get rid of that. We'll add that in there. So right now, we've got basically nothing. Let's go see. Oh, good, everything's breaking.
Did you get rid of the import?
Let us see. I may have. So I just did npm start, and great. It's rendering nothing to the screen, but it looks like we're okay. I think that the imported P is right there. So this is great because I think we do have a div up on the screen, but we're not doing anything with it yet. And you can see that right here. This is automatically recompiling when I type. So if I type inside of this div that I want text, actually I have to do p.text. This means render a string into something that can be rendered onto the page. So if we want to put some hello in there, let's clean up the stuff that they're asking us to clean up. You could press S for it to do what it wants you to do. And it looks like our file is free of errors. In order to actually get this to build, you're going to need to go in here and hit B. And that'll do a build that will actually send it to the browser. So if you're following along, go ahead and do that. And you can see we have some text now. It says hello. So inside of our name generator file, we've just got our init function, which is an empty string, our update function, which is doing nothing right now. It's just returning state on the one no-op action that we have. And then we've got our view function, which is just rendering some text for hello. So let's throw this, instead of this being hello, let's throw an h1 in here. P.h1. So P, in case we didn't see, we've imported pucks.html as P. We've aliased it to P to make it easy to use. And we know to do that because we have read through this guide, and we see that we have pucks.html here, and inside of it, we've got a bunch of stuff we can use, a bunch of tags. So we've got p.h1, and each of these tags that we use with pucks is going to take in a string of an array of attributes, and then an array of children that are HTML nodes. So we have no attributes. Let's just go ahead and type p.text. Enter your name. Now, we're not being very accessible friendly here because we should have this be a label. But we're going to move along for right now. Okay, no errors, that's good. Let's go back to the browser. We won't do this as much, but I just want to make sure that everything is working as it should, which it doesn't appear to be. Let's build it again. There we go. We've got an H1. This is enter your name. Great. So let's add an input. So we're going to do p.input. Now we need some attributes. So where do we get attributes? Well, there's a nice little part of pucks called pucks.attributes. And that's got a bunch of attributes we can use in it. So let's import pucks purescript.html.attributes as PA. I'm going to namespace all of these. You don't have to do this when you're doing it, but it makes it easier at first to tell what's coming from where. So here we're going to add the type attribute. So input, we have to give it a type of text. So input type, and it's followed with a dash since type is a keyword in the language. Type of text. Cool. I've got a thing. Does it do anything? That's the question. And the answer is going to be no. Oops, that's the wrong window. Great. So it's just an input that does nothing. It just sits there. Well, we want it to do something. So let's see. First of all, let's see if we can bind it to our existing model. And the way you do that is by sending it the value. So pa.value, we'll make it a value attribute. And we're just going to hand it the state, since the state is a string. And that's all we're keeping track of. So now when we type inside of that input, we're going to see nothing because it's bound to the empty string. We're going to need to follow the Elm application architecture in Purescript. We're going to need to generate a new action when we type inside of that window, inside of that input. And that action is going to call the update function, and then we'll update our model based on the content of the action. So Pux has this little section called events, where we can get an onChange. Cool. So what does onChange do? OnChange takes a function that takes a form event and returns an action, and it's going to return an attribute. So we need something that's going to take a form event and return an action. And let's see what form event looks like. Form event. A form event is a record that has a target attribute and a current target attribute. And target, what does that look like? Well, there are like 10 bajillion of them. Oh, here it is. Target has a value that's a string. So this is exactly what we need. We need something, we need a function that's going to take a record that has target value on it, and it's going to return an action. So up here we have our action definition. Data action equals no-op. Now if you're coming from Elm, this is basically saying type action equals no-op. So data is the word that you use to make a new algebraic data type, rather than a type alias, for example. So here, let's go ahead and turn this into a union. So equals no-op, and then let's add in something called input changed. Now, it said we needed a function that was going to return an action. So let's give the right arguments to this data type, this data constructor. That will allow us to just use it as the function. Because a data constructor with no arguments is a constant. Okay, I'm going to stop for a second and stop the share and restart it because thank you. Thank you for calling me out, Halo Special. That should be better now. Okay, so we're all back together. I was checking to see if I'd left anyone behind. And so we're almost done with the presentation part. When we're done with that, we'll just hack around and we can help each other if we're lost. So this, since it has no arguments, is going to be a data constructor. This, we're going to add some arguments to. I'm sorry, I'm getting all this stuff. Since it has no arguments, it's going to be a constant that you can use in your active value and a data type. But this, we're going to give it some arguments, and it's going to become a function that we can use to construct a value. And it will also work as a data type. And there's more to talk about there too. But basically, what we need here is a function. Remember, we need a function that takes in a form event, which is a record, and returns an action. So up here, let's make this that function. This is going to take a form event, which comes from PE, which we're going to import up here, which is import pux.html.events as PE. So now we've got a function here because Purescript generates a function for us from this data declaration called input change that takes a form event and returns an action. So let's go ahead and call that down here. Let's say pe.onChange, and we'll pass in input changed. And I think that's all we need. Oh, okay, so we saved it. Oh, good. So it's telling us now that our update function no longer covers all of the inputs that we've defined up here. It's saying, hey, you're only handling the no op, you need to also handle input change. So let's add a case for that. Let's add a new body of this function. Update input changed, and what we're going to get is the event out of it. And what we're going to want to do is I'm going to replace the entire state with the value of that event that's coming in. So I'm going to say event.target, because it's a record with a target field, and then .value, because that target is a record with a value field. And that should give us a string back that we can replace the existing state with. So I'm going to save, and let's see what's going on here. Update no-op state. That's because there is no arguments. Oh, input changed. We forgot to add the state on the end here. So input changed event, what we're going to do, we're data matching here. We're pattern matching, I'm sorry. We're saying that if we get in an action of type input changed with an event in it. And that fixes our problems. So let's see what it looks like in the browser. Does it update? Yes, it does. Great, and we can prove it if we want by dropping right down here a p.h2 that says p.text, your Falltober name is, and then let's just drop in a p.text of state. Okie dokie, let's try that in the browser and see how that comes out. Woo! Woo! So we have an updating function. We have an update function that updates the state. And that's all we need. We'll build some incredible apps now. No, I'm just kidding. So let's add a function here that's going to translate our name into the Falltober name. So let's say get Falltober name is a function that takes a string and it's going to return another string. So get Falltober name takes the input and is going to return the output. So let's do something silly with this. And the example I did was I turned them all into A's, right? So let's do that again. And that'll give us a good example of how to use maybe some of these other libraries. So we were talking about earlier how the string, let's say we wanted to map over every letter and turn it into an A. Well, the string doesn't let you map. It's not actually a functor. So what we need to do is we need to get it to the point where it is a functor so we can map over it. And if you look at the string library, let's just search let's go to pursuit.purescript.org. This is the package list that has most of the packages on it, but not all of them right now. I think it needs to be updated. If you just search string with a capital S, you're going to get a ton of things. So let's search data.string. That's the library for strings. And I don't know how to tell you how to know that other than this. That's what it's called. There's some stuff you just have to like hear. So here's the stuff that we can do specifically with strings. And one of those things that we can do is convert it to a char array. And we can also do from char array. So we can convert the string to a char array, map over the chars, and convert it back to a string. So let's go ahead and do that. Luckily, I think that Purescript strings is already installed. I think that's part of a default installation. So I think we can just import data.string, and then we can expose from char array and to char array. So down here at the bottom, let's go ahead and type, well, what do we want to do? We want to say from char array input, I'm sorry, to char array input. And then we want to pass that whole thing. So I'm going to drop a $sign here. This is just like Haskell to from char array input, or to from char array. So this $sign means everything that it is to the right of the $sign, go ahead and evaluate it first and pass its return result to the next thing that's on the left side of the $sign. So this makes it nice to kind of like chain functions. It gets rid of some of the parentheses. So right now what we should have is a function that does pretty much nothing. Oh, look at that. Unknown name, unknown operator, $sign. That's because $sign comes from Prelude. So we have to import it. I look, we'd already imported the string right there. So once we save it, what we get is we get a function that does nothing. Takes the input string, turns it to a char array, and then turns it right back to a string again. So in the middle, we want to go ahead and map. So let's throw in a $sign here and say map, and then we're going to pass it in on this function. And what we'll do is we'll give an argument here. So map char, and instead of doing something to the char, let's just return A. Save it and see what happens. Unknown value map. That's because map is also part of Prelude. So we bring in map, and now we know that we're mapping over something that can be mapped over, which is a char array. We know that because char array, if we go and look at it, we see that it's an instance of the functor type class, which means it can be mapped over. So anything that is an instance of the functor type class, you can use map on. So we get in a char, we're going to return a different char, we're going to return it back to a string. So let's go ahead and render out the faultober name by saying text get faultober name state. And let's see if it works. Did it work? Enter your name. Apples. Yeah, it's not working. What's going on here? Oh, I didn't hit build. Whee. Someday we'll have computers advanced enough to rebuild automatically. So I'll type apples, and it's all working down there. It's just returning A for everything. So there we have a basic Purescript app. Something that builds, something that runs, something that mutates the DOM. Sorry, not mutates, but updates the DOM using React. So now what I'd like you to do, we've gotten kind of back to the starting point. I'd like you to take that faultober name function and do something a little bit more interesting with it. Turn it into something that's kind of fun. Because there's a lot you can do there, like reversing the string, or like maybe do some cool thing where like for every letter you go ahead and you calculate the derivative of the number that would have been derived from that letter, and then like, you know, take the inverse something something, and then maybe you come up with a number scheme, and then you can put them back to ASCII characters. It's up to you. But I'm going to stop presenting now, and we're just going to start hanging out, and you can go ahead and ask questions. And since it's just Halo Special on the Fuse meeting with me, I'm going to let him ask him over Slack if he has any questions or if he's participating. Otherwise, we'll end the meeting and say thanks to everyone who's watching, and thanks to those who care. Bye. Bye.